Hello everyone. Um, Welcome to another college algebra lecture. So we're gonna today talk about the first part, solving basic equations, and we're gonna go through some examples. So the first thing I just want to kind of like go over those properties. Probably you know this from fundamentals of algebra. But if you have an equation, then you can add the same quantity or subtract the same quantity from both sides. And if you have an equation again, you can multiply both sides by the same quantity or divide by the same quantity. Of course, whenever you multiply or divide, that quantity should be different than zero. So just be careful with these. These are the major rules when we're solving an equation, and we try to isolate the unknown. And the first type of equation is just the linear equations, of course, in which the variable has power 1. And here a and b are simply constants, and x is the unknown. And we try to, when it says solve this equation, you try to find that unknown, which makes the statement correct. But you will see that better on the examples. Now, the first example that we have here is solving this equation. 7x minus 4 equals 3x plus 8. So what we mainly do in here is to isolate x. So whenever you do this, you simply put the variables on one side of an equation, okay, and then on the other side you try to put the constants. So you see, you try to combine them. Like in this equation, I have 3x here. Let's put the variables on the left side. You can also like put the variables on the right side and the constants on the left side. That's fine. That'll give you the same answer. Now, you can subtract 3x from both sides, because you see that will simply take this 3x to the left side. It will just simply disappear on the right side. And then the next thing, you want to remove this 4 to the right side, so I add 4, just the opposite. So now these two will cancel, the 4's will cancel, and here those 3x's will cancel. See, 3x minus 3x 0, and negative 4 plus 4 is 0. So on the left side I got 4x, and on the right side I got 12. So the final step, I want to isolate x, so I divide both sides by 4. These 4's will cancel, and I got x equals 3. So that's the final answer. You may check it with the equation, but you don't really have to, because we don't have any fractions. Because in the fractions, the denominator can become 0 with certain numbers, so you have to be careful when you finalize your answer. But for this one, you don't have any fractions, no restrictions on x. X can be anything, so we just figure out that it should be 3 if you want to make this statement correct. So the next one, we have a fraction now. And for the fractions, there's some concept that's commonly known as the LCD, the least common denominator. The least common denominator is the smallest number, or in this case, they're all numbers, so it's going to be the smallest number, or the smallest polynomial if we have multiple factors. That is divisible by each denominator. Simply, it includes each denominator as a factor. Like I have 6, 3, and 4, the smallest number that includes each one as a factor. Now, one way is you can find the multiples of 6, which is the biggest one. So 6 times 2 is 12, and then 18, and so on. You see, 12 includes all of them as a factor. So the LCD becomes 12. So it's kind of like that number that includes each number as a factor. Be careful. This LCD, although it says least, that's going to be the smallest, but it should include each number as a factor. Now, multiply each fraction by that number. So I have 12 times x over 6 plus 12 times 2/3 equals to 12 times 3 over 4 times x. Now do the cancellations. 12 and 6 cancel. I got 2. 12 and 3 cancel. Got 4. 12 and 4 cancel, and I got 3. So you see, like, I got 2x plus 8 equals to 9x. See, Now that is a linear equation. This was a linear equation as well because all the denominators are numbers. So these are simply like real numbers, the coefficients of x. But now we don't have any fractions. So we can apply the method that we have. Let's put the variables on the right side. So I can subtract 2x from both sides. And then these two will cancel. So I got 8 equals to 7x. Then I can divide both sides by 7 because I want to isolate x, leave it by itself. So x becomes simply 8 over 7. Again, you don't have any restrictions on x because there's no fractions that, I mean, you will see, for example, look at this example. Like, you definitely know that x can't be 2. When I say a restriction, that's what I mean. X can't be 2 here, x can't be -1 in here. But in here, you don't have any kind of fractions at which the denominator is x or a factor including x. So you can check it, but you don't really have to. So 8 over 7 is the solution to this problem. So now we have another rational equation example. Now in this case, I mean, of course, we need some sort of like factoring. Now let's take a look at this problem. Folks, now for the LCD, you have x plus 1, x minus 2, but you need to factor this one. And how can you factor that? It's a monic polynomial, and usually for these examples, the factors are given in the other two rational expressions. But you can check this, like now x squared minus x minus 2. And I'm looking for two factors of -2 whose sum is -1. So that's going to be -2 and +1. So as we expected, we really get the same factor. So it's like x minus 2 times x plus 1. So that means if you multiply, so that means this is your LCD because this quadratic function already includes, or this quadratic expression already includes these two as factors. So that's going to be your LCD. So this will be our LCD. See, remember the LCD was the smallest quantity that includes each factor of each factor, like each denominator is a factor. So here x plus 1, x minus 2 is already included in that one, so that should be the LCD. Now, if you multiply everything by LCD, you should be able to get rid of all the fractions. So I have 1 over x plus 1 and multiply by x plus 1 times x minus 2 plus 1 over x minus 2 multiplied by x plus 1 times x minus 2. And then equals to, I have x plus 3 divided by x squared minus x minus 2, and that's multiplied by x minus 2 times x plus 1. Now be careful, these two will cancel because if you factor that one, you will get x minus 2 times x plus 1. So these two are the same, the one at the top and the one at the bottom. X minus 2 times x plus 1 and x squared minus x minus 2, they're the same, so they cancel. Here x minus 2 cancels with the x minus 2 here, and x plus 1 simply cancels by this x plus 1. So if you simplify, you get from here x minus 2 plus from here I get x plus 1. And on the right side I got x plus 3. So now we have a linear equation. But be careful. Here x can't be -1 because that makes denominator 0 here, and x can't be 2. I'm going to show you an example in which that may happen at the end, but I think it doesn't happen in this problem. Let's see. So I have 2x. I combine these two, and I can combine -2 and +1. So I got 2x minus 1 equals to x plus 3. Now subtract x from both sides, right? And then add 1 to both sides. See, like these two will cancel, and these two will cancel. So I got x equals to 4. And 4 does not make any of the denominators 0, so yes, that's the solution. So if you, for example, end up by 2 or -1, then you will say no solution. I'll just show that in the next example. So yeah, that's just one example with the rational equations. So now let's look at next example, which is kind of the problem that I was just talking about. And now, I mean, of course, you have two fractions in here, but you may simply write this as a fraction as 2/1, and the LCD will be easy here because 1 really does not count. That's like every quantity simply includes 1 as a factor. But I have x minus 4, so that should be x minus 4. See, if you multiply everything by x minus 4, you will get rid of the fractions. Now I have 2/1 times x minus 4, and then I have plus 5/x minus 4 times x minus 4. See, again, I'm multiplying each one by x minus 4. On the right side, I have x plus 1 divided by x minus 4 times x minus 4. So I multiplied each expression by x minus 4. See, these two will cancel, and these two will cancel. Now let's simplify. So I can distribute that 2 to both terms. I got 2x minus 8. From here I got plus 5 equals x plus 1. And I can combine these two. So you see, these two. So I got 2x minus 3 equals x plus 1. And next I apply the same argument. So I'm subtracting x from both sides to get rid of this x on the left side. And then I'm adding 3 to both sides to get rid of this 3 on the left side. Don't forget, on the left side I have the variables, on the right side I have constants. You can do it swap. You can put the variables on the right side and the constants on the left side. That will give you the same equation. Now, finally we got x equals 4. But we have a problem here. This can't be a solution because this 4 makes denominator 0. See, like from here, we already assume that from here or from here, we already assume that x is not 4. Because that makes denominator 0. So that means we only come up with 4. That means this problem has no solution. Just be careful, folks, for these type of problems. This one has no solution. So next we will go into solving the power equations. I mean, that's if you have something of the form x n equals a, then you will simply take the nth root of both sides and that will give you x, if of course the power is simply odd. And if it's even, then that a needs to be positive and then you got minus plus in there. Like for example, I mean, if you have x squared equals 4, that will imply x equals minus plus 2, so you have two solutions. But if you have x squared equals negative 4, then we just simply say no solution. I mean, in the future maybe we can work with if you work with the complex numbers, yeah, you may get a solution, but right now we have no solution. And we just say here no real solution. That's why. You don't have any real numbers that satisfies that, so I just say no solution. Now let's go over some examples about that. So like these first two is just similar to what I said, like from here, for example. From here you can write x squared equals 5, so I got two solutions, x equals minus plus square root of 5. So, I mean, you can write it separately, or you can, if you want to enter that separately, that's going to be x equals negative square root of 5 or square root of 5. So two separate solutions, I mean two solutions. Okay. So like for example here, it's just similar, but this time it will simply isolate x minus 4 first. So I have, from here I got x minus 4 equals minus plus square root of 5. So I add 4 to both sides to isolate x. But you can't combine these two. That's like a radical expression. That's it. That's a whole number. So these two will cancel. So I got x equals 4 minus plus square root of 5. I mean, we just write this as x equals 4 minus square root of 5, or x equals 4 plus square root of 5. I'm going to write them separately. So there are some like simple type of problems, but I want to say, for example, if you have the cube root, that really works for any number, and you see now you're going to take the cube. I mean, you can really try that one with a calculator, that will work. But if you look at x as the cube root of -8, and I would like to say here, really, that's an odd power, so that will exist. I mean, and you see it will be -2, because if you multiply -2 3 times by itself, you will get -8. So that's kind of like that quick check. So here, x will be -2. You can just check that, and you don't have any minus plus because that's an odd power. Or for example, look at this one. You need to again isolate x, so I divide both sides by 16. So these two will cancel, and I got x to the 4 equals 81 over 16. Now I want to say you have to just do those observations. Like again, you may use a calculator, but this 3 over 4 is, for example, 81, and then 2 over 4 is simply 16. See, like you have 3 over 2. So that will imply that you got x equals minus plus 4 root of 81 over 16. But you will see that will be 3 over 2. So x will be simply 3 over 2 or -3 over 2. So you get like two solutions for this problem. See, that's like again an even power. Like here in these even powers, you got two solutions, and here you got two solutions as well. Yeah, it's kind of like sometimes you may just say that you're taking the 4th root as, and I just want to mention that one, but you may just say you're looking at this 81 over 16 to the power 1 over 4. That's what you have with the minus plus. Those are the same. So these two are the same thing. So taking the 4th root means you're taking the 1 over 4 power. So here's another problem, a little bit, may just look a little bit tricky, but it's not really that bad. Here, you see, I mean, the way you try to isolate x is simply you add 2 to both sides. So I got 5x to the 2/3 equals to 45, and then next step you divide both sides by 5. So 5 will cancel, and I got simply x to the 2/3 equals to 9. Now the thing is this, you're going to flip that one to get 9, but since you have 2 here, actually you're taking the radical. It's kind of like you're taking the second root because you're flipping that one. It's kind of you're applying 3 over 2 here, and this over 2 means that's like you're taking the kind of even root. So that means this will imply a minus plus. So here x will be simply minus plus 9 to the 3 over 2. And that will be, it's kind of, you may think of this way, 9 to the 1/2 raised to the 3rd power. This is like 3 to the 3rd, which is going to be 27. A calculator can easily show that to you, but don't forget there's minus plus because of this even root, the second root. So here x will be minus or plus 27. That's what we have. It may look like a little bit tricky one, but that's how we get that. See, like here you take the 4th root, that's why you put minus plus. But here, for example, in this problem, you're taking -8 to the 1 over 3. So that's why you're not putting minus or plus, because that's like taking the odd root. So these are like really nice examples about that. And I have one final problem, which is simply about the variables. Solving this one for R, and let me put some space for that. Yeah. So trying to here isolate R. It's like R is your unknown variable. So you can leave it right here. That one has an R and that one has an R. So when you solve a problem like this, you try to combine R terms, which is your variable term, into one side and the non-R terms to the other side. Then that'll be easy. For example, this is a non-R term. Let's say we have non-R terms on the left side and the R terms on the right side. Okay? So in that case, these are at the correct side. This E is on the correct side, but 5 is not on the correct side. So let's subtract 5. This is really common in many application problems, so that's why we include that one. So E minus 5 becomes IR plus 2R. Now you see both of them as an R, so I can factor R out. So I got E minus 5 equals I plus 2 times R. So I factor R out on the right side, and then finally I can get R. I divide both sides by I plus 2. See, like these two will cancel, and I got R. So from here, that implies R needs to be E minus 5 divided by I plus 2. This is how you solve it for R. Okay. So I hope you like this video. I hope this will be helpful. Thanks for watching. Bye.